Welcome to section 613. We're going to be talking about finding inverses and justifying or verifying that functions are inverses of each other. So a little notation to talk about. We have that function notation. When we talk about an inverse, we say f inverse of x. That's what that little -1 is read as, f inverse. So when we find an inverse, if it's in function notation, we replace f of x with y. Then we switch the x and the y, and then we solve for y again. So for number 1, it's y equals. So to find the inverse, set x equals to the square root of y minus 2 plus 3. Now, what we want to do is isolate the y. So we're going to subtract 3 from both sides. So we get the quantity of x minus 3 equals the square root of y minus 2. Now we want to get rid of the square root, so we square both sides. Now make sure you square the entire left-hand side. So we get the quantity of x minus 3 squared equals y minus 2. And then you can add 2 to both sides. So y equals the quantity of x minus 3 squared plus 2. There is our inverse. And we're going to leave it just like that. It wasn't in function notation in the beginning, so we'll just keep it as y equals. Now, for problem number 2, this one is given in function notation. So the first thing we do, instead of writing f of x, we say y equals 4 minus 2x over 5. Then we switch. X equals 4 minus 2y over 5. Put the x over 1, and then we cross multiply. 5x equals 4 minus 2y. Remember, we're just solving for y, so subtract 4 from both sides. 5x minus 4 equals negative 2y. And then divide everything by negative 2. So y equals negative 5 halves x plus 2. Now, since this was given in function notation, we're going to write our answer in function notation. So instead of writing y, f inverse of x equals negative 5 halves x plus 2. And there we found our inverse. Number 3. We have this restriction that says x is greater than or equal to 0. We'll talk about that in a little bit. There's a need for that we'll get into. So once again, it's in function notation, so we'll set y equals to 3x squared minus 2. So switch the x and the y. X equals 3y squared minus 2. Add 2 to both sides. X plus 2 equals 3y squared. Divide both sides by 3. X plus 2 over 3 equals y squared. And now to solve for y, we take the square root of both sides. So we get y equals, remember, 2 square roots plus or minus the square root of x plus 2 over 3. Now here's where this restriction comes in. X is greater than or equal to 0. Because it's greater than or equal to 0, we're going to use the positive square root. So when we write our answer in function notation, f inverse of x, we're going to use the positive. So just the square root of x plus 2 over 3. That's where that restriction comes into play. Problem number 4. It's just y equals, so we won't worry about function notation here. So we just switch the x and the y. X equals 2 times the quantity of y minus 1 cubed. We want to isolate the binomial, so divide both sides by 2. X over 2 equals the quantity of y minus 1 cubed. And then take the cube root of both sides. So you get the cube root of x over 2 equals y minus 1. Add 1 to both sides. Y equals the cube root of x over 2 plus 1. It wasn't in function notation to begin with, so we're just going to keep it as y equals. All right, next page, please. Here we're going to verify. And to verify that they're inverses, f of f inverse of x has to equal x, and f inverse of f of x needs to equal x. We're using those composite functions. So for the first one, f of f inverse. So that's f of f inverse of x. So it's going to be f of 1/4 x minus 1/2. So we substitute wherever we see x. So it's 4 times. Instead of x, we'll leave some parentheses, plus 2. And here's where we substitute. It's 1/4 x minus 1/2. So distribute the 4. 4 times 1/4 x is x. 4 times negative 1/2 is negative 2 plus 2. So you get x. So f of f inverse of x equals x. That one's good. And now f inverse of f of x. F inverse of 4x plus 2. So for f inverse, it's 1/4. Instead of writing x, we'll leave some parentheses, minus 1/2. In the parentheses where we substitute the 4x plus 2. Distribute your 4. 1/4 times 4x is x. 1/4 times 2 is a positive 1/2 minus 1/2. X plus 1/2 minus 1/2 is x. So there's f inverse of f of x. Since they both equal x, they are inverses of each other. And that's how we verify. We didn't find the inverse, we just verified. All right, let's go to problem number 7 now. Once again, we're finding the inverses. So we're going to use our function notation. So the first thing we do is replace y with f of x. F of x equals 3x minus 9 over 2 plus 20. So what we have is x equals 3 times the quantity of y minus 9 over 2 plus 20. And we're going to solve for y. So undo addition, subtraction. Subtract 20 from both sides. X minus 20 equals 3 times the quantity of y minus 9 over 2. To get rid of the 3, divide both sides by 3. X minus 20 over 3 equals y minus 9 over 2. Now to get rid of that 2, multiply both sides by 2. So we get 2 times the quantity of x minus 20 over 3 equals y minus 9. Add 9 to both sides. So y equals 2 times x minus 20 over 3 plus 9. And now to write this in function notation, f inverse of x equals 2/3 x minus 20 plus 9. And there's our inverse function in that function notation. Now for b, once again, replace f of x with y. 3 plus x over 4. X equals 3 plus y over 4. To get rid of that division by 4, multiply both sides by 4. 4x equals 3 plus y. Subtract 3 from both sides, y equals 4x minus 3. So to write our answer in function notation, f inverse of x equals 4x minus 3. Part C. Replace f of x with y. So y equals 1/3 times the quantity of x minus 1 cubed plus 6. So what we can do is we can subtract, x equals 1/3, y minus 1 cubed plus 6. Subtract 6 from both sides. X minus 6 equals 1/3 times the quantity of y minus 1 cubed. Multiply both sides by 3. Use your grouping symbols on the left, so you get 3 times the quantity of x minus 6 equals y minus 1 cubed. We don't need to distribute the 3. You can if you'd like. And now we're going to take the cube root of both sides. So the cube root of 3 times the quantity of x minus 6 equals y minus 1. Now to get y by itself, add 1 to both sides. Y equals the cube root of 3 times x minus 6 plus 1. So for function notation, f inverse of x equals the cube root of 3 times x minus 6 plus 1. If you distributed, you'd get f inverse of x equals the cube root, and it would be 3x minus 18, and then plus 1 at the end. So you could have either one of those, depending on if you distribute it or not. They're both equally correct. And for part D, once again, replace f of x with y. So y equals 2 times the quantity of x plus 4 squared minus 3. Take note of that restriction. We'll come back to that at the end. So x equals 2, x plus 4 squared minus 3. So we're just, that's a y plus 4. We add 3 to both sides. X plus 3 equals 2 times the quantity of y plus 4 squared. Divide both sides by 2. X plus 3 over 2 equals y plus 4 squared. And then you take the square root of both sides. So you get plus or minus the square root of x plus 3 over 2 equals y plus 4. And then you subtract 4 from both sides. So y equals negative 4 plus or minus the square root of x plus 3 over 2. Now here's where that restriction comes into play. X less than or equal to 0. Since it's less than or equal to 0, it's a negative. So use the negative square root this time. So f inverse of x equals negative 4. Instead of putting the plus or minus, you're just going to use the negative square root of x plus 3 over 2. And there is our inverse function. And problem number 8. We're just verifying. We're not finding the inverse, just verifying. So we're finding f of f inverse of x. So it's going to be f of, in this case they use g of x instead of f inverse, but it's the same process. So f of g of x, so it's f of 3x minus 1. So in that function f, instead of writing x, we're going to use some parentheses. Plus 1 over 3. So in the parentheses, 3x minus 1. So we get rid of the grouping symbols, 3x minus 1 plus 1 over 3. So that gives us 3x over 3, which is x. So there's f of g of x. Next, we want to find g of f of x. So that's g of x plus 1 over 3. So in function g, it's 3 times, instead of x, parentheses, minus 1. In the parentheses, we put our x plus 1 over 3. So when you multiply by 3, the 3's cancel. We're left with x plus 1 minus 1, which is x. So there's g of f of x. Okay, and that's how we verify inverses. Thank you for your time, and I will see you in the next